This question is from GATE Mechanical Engineering 2021. This is question number 47 of set 1. The question is, a cylindrical jet of water of density 1000 kg per meter cube impinges at the center of a flat circular plate and spreads radially outwards as shown in the figure. So this is the figure given. The plate is resting on a linear spring with a spring constant equal to 1 kilonewton per meter. The incoming jet diameter is 1 centimeter. If the spring shows a steady deflection of 1 centimeter upon impingement of jet, the velocity of the incoming jet is in meter per second. So we need to find the velocity of the jet that hits the flat and circular plate in the middle, and that too rounded off to 1 decimal place. Let's understand this problem using this diagram. Now let's suppose when the velocity of jet hits this flat plate, it gets deflected by distance x, or I can say it get compressed by x. Not the plate, but this spring get compressed by a distance x. And we need to find the this velocity. Now from Newton's second law of motion, we can write F is equal to d upon dt of momentum, right? So force vector is the change of momentum. Here we can write F is equal to m mass flow rate at this point A1 multiplied by velocity in y direction, because we are considering this vertical direction as y direction, at 1 minus m2 mass flow rate at this point 2 and vy2 velocity at this point. Now we see here that velocity at point 2, it will be 0 because the fluid will strike here and it will come to rest. So this term goes to 0. Now from conservation of mass, we can write mass flow rate will be equal to density multiplied by the area and multiplied with the velocity with which it is traveling. So it is traveling with Vy1, this velocity. So let me write it here, Vy1, and this is m1. And rho is the density and A is the area of cross section of this jet. Okay. Now if we substitute this mass flow rate in this force equation, we will get force in y direction will be equal to rho A Vy1, that is the mass flow rate, multiplied by Vy1, velocity in that direction. And this can again further, we can write this as Vy is equal to rho A Vy1 square. Okay, let this be equation number 1. Now we have only one force acting in the y direction, Fy, that is the spring force. And spring force Fy can be written as Kx, where K is the spring constant and X is the deflection. So the plate here, it is moving by a distance x. So let this be equation number 2. So from equation first and second, we can write Kx is equal to rho A Vy1 square. And here we need to find the value of this velocity, Vy1. Okay, so Vy1 will be equal to Kx divided by rho into area, that is density into area, square root. Now in this equation we have the value of K, that is 1 kilonewton, or let's write 1000 Newton per meter, and the deflection X is equal to 1 centimeter, or we can write 0.01 meter. We are writing all terms in SI unit. And diameter of the pipe or the jet is given as 1 centimeter. So that will be again 0.01 meter. And the density given is 1000 kilogram per meter cube. Kilogram per meter cube. So we need area. Area will be equal to pi by 4 into d square, and that comes out to be pi by 4 into 0.01 square. This is equal to 7.85 into 10 to the power of minus 5 meters square. Now let's substitute all this value in this, let's say, equation number 3. So what we will get here, the velocity in y direction will be equal to square root of k. So k value is 1000 into 1 centimeter, that is 0.01 meter, divided by density, that is 1000, multiplied by 7.85 into 10 to the power of minus 5. This is area. So this value comes out to be, so Vy we will get 11.28 meter per second. So if we round off it to one decimal place, we can write it as 11.3 meter per second. Let's go back to the question and fill in the blank. Velocity of incoming jet is 11.3 meter per second. To get more information, you can follow the NPTEL course of Fluid Mechanics by Professor S.K. Som of the Department of Mechanical Engineering at IIT Kharagpur.